Talk's due to start in a few seconds, but we're going to wait a minute or so for people to wander in from the break, and then once that's done, once I start the talk, I'll hand over to you, and you can drive the screen and all the rest of it.
Okay, so once I start sharing screen, then I can simply go ahead, right?
Yeah, I say I'll do a brief introduction. I'll take off this this overlay slide, and you can share your screen, and then you can go.
Okay. So yeah, I got an opportunity to speak at PyConZA. So it's something I got a last minute opportunity. I checked the schedule and I've seen there was a talk was cancelled, so I thought to check it. I thought checking with the organizers, and fortunately I got accepted. So I'm so happy for that.
Sort of people are starting to trickle in to watch the YouTube stream, so I'll just give it another 30 seconds and then we can start.
Yeah, sure.
All right, I think we can start. Welcome to the first talk in video room 2 of the afternoon session. Our speaker is Kalyan, who has very kindly stepped in to replace our scheduled speaker, who unfortunately had to pull out because of a family emergency. So we are very grateful, and we look forward to an interesting talk. Share your screen. You can take it away.
All right. Share my screen. All right. So we are good to go now?
Yep, you're good to go.
All right. Hello everyone, and thank you so much for giving me the opportunity in the last moment, and I'm so happy to speak to you at PyConZA today. So today I'm going to talk about NeuralProphet, a powerful AI framework for time series models. Myself, Kalyan Prasad, a self-taught data scientist and analytics manager, and I'm also a community-first person. So I love being with various tech communities, and I like community to help them. And currently, I'm a core member of Hyderabad Python user group, PyCon India, PyCon Hyderabad, and Humans for AI. I'm also an avid speaker because I always look to give back to communities by sharing my knowledge, whatever I know. So that's how I look for opportunities to speak. And I'm also a lifelong learner and passionate mentor. So that's pretty much about me. And here is the agenda for today's talk. So we'll be quickly giving an introduction about time series. Then we'll talk about what is NeuralProphet, and then why we need NeuralProphet. And then we'll switch about what is the difference between the original prophet and the NeuralProphet. Then we'll straight away jump into hands-on to see some action about NeuralProphet. And finally, we'll conclude our topic on it. So feel free to drop your questions if you have anything at any point of time. I'll be addressing each and every question at the end of the talk. Okay, without any further delay, let's get started. So what is time series? There are so many definitions on the internet of the time series, out of which indicate same meaning in a different way. A very straightforward definition is sequential data order matters. Time series is a sequence of observation taken sequentially in time. When forecasting time series data, the main aim is to estimate how sequence of observations will continue in future. So observations are typically collected at regular intervals like every week, daily, yearly, monthly, etc. For example, if you are talking about weather data, we may receive weather updates for every 10 minutes or every 1 hour. Or if you are talking something about IoT sensors like that, so that generate data continuously. So depending upon the source of the generation, we may have different frequencies at which data is collected. Advancements in machine learning have increased the value of time series because there are so many prediction problems that involve time series component. That is why it is like booming in the industry now. Organizations apply machine learning to time series data to make informed business decisions. They do forecasting, they compare seasonal and cyclic trend because time series forecasting helps us to predict the future values of a critical field which has a potential business value in the industry. For example, predicting the health condition of a person, or predicting the performance of a sport, or predicting the performance of a player based on the previous data, or something like that. I believe that time series has spreaded its wings completely. So that is why it is there everywhere in every industry. Now here comes our main topic, NeuralProphet. So here is a quick visual representation about NeuralProphet. So it is a Python library for time series forecasting. NeuralProphet is a neural network based model that uses PyTorch as a backend, and it has a modular architecture that allows so many features to be plotted in the future. And this library is heavily inspired from Facebook Prophet in ARNet libraries. And the author of these libraries are the researchers from Stanford University and Monash University. What more we need to know about NeuralProphet? This library is absolutely a beginner friendly. One can easily set up and start building time series models, which you'll see in some time. It addresses pain points such as scale, customization, and extensibility. This library is completely scalable. You can also customize or modify or adjust your model according to your needs. And of course, you can also manipulate or edit your code without changing your existing code base. So that's the beauty of this library. Just like Prophet, NeuralProphet is also decomposable with all time series decomponents like trends, seasonality, auto regressive, lagged regressive, future regressive, and recurring events. This library is absolutely an upgraded version of Prophet because it uses deep learning models such as ARNet for forecasting time series models. Now, why we need NeuralProphet? It aims to solve the seesaw of uncertainty. So what do I mean here? So I assume you are aware of autoregressive models. Autoregressive models are nothing new, but usually you would fit a linear regression. You would use a linear regression fit with a least square instead of a neural network fit with a back propagation. ARNet mimics the traditional AR process with a neural network. It is a single layer network that is trained to mimic the AR process in a time series signal, but at a very large scale than the traditional AR, than the traditional models. ARNet also scales much better to larger data sets and more inputs. For example, if you look at this below graph, the training time of a auto-regressive, the training time of a ARNet doesn't increase exponentially with AR order. So here is ARNet, here is AR order. So the training time doesn't increase exponentially when you compare with AR order. One thing I would also like to stress here is about the p-values. So the p-values here are the number of autoregressives used in the autoregressive models, not the p-values that we use in the null hypothesis testing. Apart from ARNet, NeuralProphet also upgrades Prophet linear external regressors to feed forward neural networks because deeper equals to better. So the deeper equals to better means the better we can train our models, the better we'll get an accuracy, the better we have results. So that's the beauty of the NeuralProphet. Lastly, adding neural network to the Prophet has a downside because the learning parameters increases dramatically. So to cope up with that, NeuralProphet relies PyTorch framework as a backend instead of STAN and trained with a stochastic gradient descent. That's again an amazing feature for the NeuralProphet. Now, what's the difference? First things first, as the name suggests, NeuralProphet is similar to Prophet, but it throws some neural network in the mix to spice up things. When you are exploring time series data at any point of time, you will definitely encounter a popular package called Facebook Prophet because it gained a lot of popularity due to the fact that it provides a very good results in terms of accuracy and interpretable results. The best part of a Prophet is it automates a lot of elements. For example, hyperparameter selection, feature engineering, etc. for the users. That is why it is very straightforward to use for a data scientist or any other folks who are playing with time series data, or even for the folks who have a very less knowledge, they can straight away use the Prophet. That's again an amazing feature. When it comes to neural profit, the author also had the same thing in his mind for this library to retain all the advantages of the profit while improving accuracy and scalability. So using ARNet, so, so using ARNet to combine the scalability of a neural networks with the interpretability of AR models. So that's the amazing difference between the profit and neural profit. So here are the main core differences and the features which are available in the neural profit comparatively with the original profit. The first one is a gradient descent optimization. Since neural profit relies PyTorch as a backend, which makes model much faster. Time series autocorrelation is model using the autoregressive neural network model. And laggard resources are modeled through a separate feed-forward network, so which makes our modeling even much faster. And also, additionally, the model is configurable to non-linear deep layers of the feed-forward network. This is again an amazing feature. It also offers the custom losses and metrics, so which you can see when once we jump into the code. Apart from these amazing features, another great feature of a neural profit is it allows a developer access to the ARNet library, which was developed by Facebook researchers. So that's again an amazing feature of the neural profit. So I think I have given enough GAN on theory. So let's straight away jump into some hands-on and let's see some action now. So let me switch to my code notebook now. All right. Okay, so here is my code notebook for this presentation. Basically the goal of this notebook is to show you about the neural profit and which is used for time series modeling. Apart from that, I'll also show some iterative steps to manipulate time series data and visualize time series data, and also show some important techniques which are involved in neural profit. So again, first thing first, so to install NeuralProphet, there are multiple ways you can do it. The first thing you can simply install NeuralProphet. If you want to install NeuralProphet in a Jupyter notebook, you need to install NeuralProphet Live. This will allow you to enable the live plot loss in the fit function to give live plot for training and validation loss. Other than this, if you want to get an up-to-date version of a NeuralProphet, so simply go to the GitHub page of a NeuralProphet and clone the repository, start playing with it. So for this demonstration, so I have installed the live library here. So it takes a few minutes to install this library because this is quite a heavy library based on Torch. So it's already installed. So this demonstration notebook consists of two sections. The first section where we'll be creating a simple baseline model of a neural profit. And in the section two, we'll dig into bit detail about neural profit by understanding some additional information on that. Okay. As usual, we'll import necessary suspects here. So I've imported the libraries called pandas, matplotlib, seaborn, and NeuralProphet. I've also imported a set random seed and have initialized the random seed with random number. Here I'm giving the number as a 0 to ensure that models are reproducible when subsequent runs. So, all right. So I'm initialized all my libraries now. So, so for this demonstration purpose, I am taking the retail sales CSV data. So from the neural profit GitHub page. Okay. Apologies, so it's taking a few seconds now. Check on. All right. So let me read my sales data now. So we got the first 10 rows of our data, and let me also run the last 10 rows of our data. So here we have a data now. So just like Prophet, NeuralProphet also requires to do some reformatting on the data frame before we pass it to our model. So what I mean here is we need to make sure that date is of a correct data type, and the column should be named as a DS for a date stamp and Y for the parameter which we want to predict. So in our case, which we have already done, so there is no need to do any reformatting here. So I think we are good to proceed further now. So let's create a simple model now. So we can simply create model and validate the new bucket with very few lines of the code. So let's see that now. So I have initialized a neural profit model here, and there are so many options and parameters are available which we can pass to neural profit to improve our results. But for now, we keep things simple and let's create a simple baseline model here. So have initialized my neural profit model here, and then I'm calling my fit function where I'm passing my data and other parameters. So validate each epoch. Validate each epoch is nothing but whether or not to validate the model data, for the validation purpose on each epoch. Validity is nothing but it's a float point between 0 and 1, indicating that the number of observations should be trained on our data. Frequency is equal to D, which is nothing but we are taking a daily frequency here. Lot live loss is nothing but to get a live plot for both training and validation loss, which we will be seeing in some time now. Epoch is nothing but the number of epochs which we should be used for training. Okay, let me run this. So now you will see the live plot here. So it's running. So if you observe this live plot and notice how plot and live loss values are updating after each epoch. So if you want to check again, if you want to see again, you see how our plot and live loss are updating after each epoch. Yeah. So you see how live plot changes here. So that's again a beauty now. So next we generate a prediction. To generate a prediction for NeuralProphet, we need to have a feature data frame. So as a name itself suggests that we need to have a new data frame of a date that extends our original data frame. So let's see what it means. So I am creating here a feature data frame where I'm passing my data and giving period as a 365. So here I'm creating a 1 year feature data frame for our predictions. Then I'm passing my feature data frame to predict function to return the forecast. So once I execute this, we'll get a feature data frame. So if you remember, if you see here, our data starts at January 1st, 1992, and it ends at 1st May 2016. So if you look at feature data frame, it starts at 2nd May 2016 and it ends with 2017 May 1st. So here we got a future data frame here. And it also identifies the y hat predictions, trend, and seasonal yearly values here. So that's again an amazing thing here. And one thing we should also remember here is it is common for the y and residual values to be none. So this is an expected behavior. So you don't need to get panic on this particular things. Okay, so we are good that we also got a feature data frame. Let's plot our forecast now. So let me plot. So plotting forecast is pretty straightforward. We just need to pass our feature data frame to our model.plot. We'll get a future plot. So this is a 1 year future plot of our retail sales data. And if you notice that how the plot is able to learn the seasonal patterns for our retail sales data. So another great thing is that you can also plot the model components. So these model components are nothing but these processes known as time series D components, which I have also discussed in the slide. So you can also see the trend value. So it is a solid decreasing trend here for the retail sales data. And if you also look at seasonal yearly, it is particularly high at in the month of December comparatively with other months. So these time series decomponent plots are really important for domain expertise because they look into these components to visualize and gain insights in the overall forecasting process, and based on this they will adjust the model accordingly. So this plays a very important role for the domain expertise. So that's pretty much about a simple neural profit model. So this is how you can create a simple model of a neural profit. So let me jump into the next section now. So in this section, so we'll see why neural profit is so powerful. Neural profit is especially powerful for time series forecasting because it takes additional information into account, such as trend, seasonality, ARNet, and recurring events into account. So we'll see all these items one by one in action, and so you'll get to know more about it. So, okay. So for this demonstration purpose, I am taking a different data set from Kaggle, which is called a Nifty 50 index data. So in that, I am taking it considering a monthly company. So let me read my data here. Okay, I have read my data. So here are the first rows for our data. Let me also look at the info about the data. So here is the info about our data frame. And let's also look at the shape that how many rows and columns. So we have 4,427 rows and 15 columns for our data. So as I mentioned earlier, before we pass to our model, we need to reformat our data frame. So this is what I'm doing exactly here. So here is the new variable I'm creating and selecting my new data original data frame, and I'm selecting these two columns from the data frame, which is date and VWAP. VWAP is nothing but the volume weighted average price. So this volume weighted average price is a trading benchmark for the traders that gives that gives an overall value of a price that was traded throughout the trade. So this price is really helpful for the trader because they get insights into a trend and the value of a security. So this plays a very key role for this price really plays a key role for the trader. So I am selected that column here. Then again, if you observe here, our date is an object, but so we have our date should be in a datetime index, datetime object. So that's the reason I am just converting my date from object to datetime here. So I just apply and pass the datetime function, so which will convert from object to datetime object. That's it. Then I have set the index. So okay, now let's run this. So we'll get our date and the volume weighted average price values. Okay, let's look at the trends now. So first thing first, so let me run this. So what I have done is, so I have selected a new data frame, and I have also passed my column, which is volume weighted average price, and simply plotting here. So if you look at this graph, it shows a general increasing trend with some points where price rises or falls sharply. So most of the time it's a solid increasing trend, but there are only very cases where price rise or fall, price is rising and it's falling. So we can consider these as a change points. So with this in mind, now we'll train a neural profit model of our monthly stock price, focusing only trend as our first version of model. So meaning that, so we'll build a model only focusing trend as our model thing, and let's see how the result looks like. So before that, so as I mentioned earlier, so we need to rename the column. So date time should be a DS and our predicted parameter should be as a Y. So I'm doing the same here. So we are all good now. Let's create a model now. So I will initialize the model neural profit and passing few parameters. So with neural profit, we can create a trend forecasting time series model by passing a very few parameters here. So I have passed a few parameters here that is nothing but 10 change points, specifying the number of points in the broader trend, increase of a decrease in the data changes. So it's like a rate of increase or decrease in the data changes. Trend rate is nothing but it's a regularized parameter that controls the flexibility of a change point selection. And if you look at the yearly seasonality, weekly seasonality, daily seasonality, it false because we are focusing only on the trend. So that is the reason given as a false. Okay, now we have initialized our model. Now then we are fitting our model. So I fitted our model, we have passed my data frame and also the other parameters. So these parameters we have already seen in section 1. So it is same. Let me run my model now. Okay, so you see the live plot here now, the live plot loss. So if you observe, the live plot looks more compromising, but however, it seems like after a lot of volatility, the model has converged. So in order to understand better, so we can visualize our model predictions now. For that, what I have done is I have created a custom function called plot forecast here, where I'm passing my model, my data, periods, historical prediction, highlight steps ahead. So what your model is nothing but our trained NeuralProphet model, data is nothing but our data frame which we are using for training, periods is nothing but the number of periods which we want to forecast, historic predict is nothing but whether we want to make prediction on historical data, whether we, I mean, the history, whether we want to plot our predictions on the historical data. Highlight step ahead is nothing but the step ahead to highlight the forecast line. It will highlight the forecast line, so which is only available for auto-regressive models only. So I have created a custom function now. Then again, I'm creating a new feature data frame here. So where I'm passing my data, passing my period, historical predictions. So once I've created a feature data frame, now that I am passing my feature data frame to predict function, which will return the forecast. And here I've also written a quick conditional statement here. So if highlight step ahead is not none, so I want my model to highlight the forecast line for each forecast. Otherwise, simply plot my forecast predictions. So this is what I'm doing. So let me run this. Okay, so now, so now I have calling my function where I'm passing my model, my data, and giving period as 60. So what does it mean here is now we are visualizing our monthly forecast, monthly stock price on historical data, and it also forecasts for the next 2 months, that is 60 period. So our plot will show the historical period as well as forecast period for the next 60 days. Okay, let me plot this. So if you observe this graph, it is very evident that the model is able to capture the general increasing trend for our monthly stock price. But however, if you observe, model seems to suffer with underfitting here, particularly in the year 2019 and 2020. So these values are likely used for validation. So let's also look at the forecast plot. So we'll now plot the forecast plot where we don't see any historical data. We only see the forecast plot line here. So if you observe this forecast plot, it shows a solid increasing line, like a solid straight line. So let me tell you something. If stock price was that easy to predict, no one in the organization would generally don't hire a financial advisor to manage their portfolio. Makes sense, right? So it's not easy that it's not that easy to predict the stock price. So what we can do better in order to improve our model? So we pass some seasonal parameters here to fine tune our model. So let's jump into seasonality now. In, most often in time series, we see a seasonal pattern. So this is even true for stock market data as well. So we now pass a yearly seasonality parameters. We now pass a yearly seasonality parameter, and we'll see how our model performs. So this is what exactly I'm doing here. So I've initiated my model. Then I'm passing the same parameter which I've seen. The only thing changed here is I am making the yearly seasonality as a true. Rest all remains the same. Okay, once then I'm fitting my function, fitting my model. Then I'm passing my all other parameters. And once I execute this, looks same. The loss function, the loss plot looks almost similar. the thing I'm not running here is it takes no, a couple of seconds to run this model, so that's the reason. So if you also observe, okay, I've also run the model, so you can look now. So you see the last block looks almost like similar, but bit realistic comparatively what we have seen in the trend here. Okay. Now let's plot our forecast plot here. So let me plot our forecast. So if you look at our forecast plot, and let's also run our forecast plot. So this is a historical plot including forecast one. This is only exclusively forecasting plot. So based on the above two plots, so the model looks a bit realistic, but it still suffers with some underfitting here. And if you look at the forecast plot, it shows a smooth curve that reflects a year of a seasonality degree, that reflects a degree of yearly seasonality here. But in real time, there are very rare instances where stocks move so smoothly. If you remember, most of the time, stock market graphs looks very uneven and tangent lines. It does not look this straight or no, that perfect line. So these are very rare instances where you see these kind of setup. I mean, like very hard instances where you see these kind of increased smooth curves. So so what we can do better now? So we'll capture all this volatility. We'll capture all this volatility by using ARNet, AR models such as ARNet, and let's see how our results look like. So ARNet is nothing but so auto-regressive neural network, especially used for time series forecasting. So auto-regressive models are like a class models, so that are values that are able to predict that are able to predict the future values of the variables based on its previous pattern. So that's pretty much about auto-regressive models. So again, so what we do in this case is, so we now forecast our model by considering ARNet, and so so we want to take the historical data and of 60 days to predict the next 60 days data. So what I mean here is that we now consider the previous historical data of previous historical 60 days of the data, and based on that historical data, we predict the next 60 days data. So that is what these parameters n forecast and n lags here. So rest all other parameters remain the same, and I've initialized the model, and once then I'm fitting my model by passing parameters. Once I run this, so we'll get a loss values, mean absolute error, mean squared error, reg loss here. The thing I'm not running right now is it takes at least more 3 to 4 minutes of time to execute all this. So keeping time in full consideration and not executing this because it takes few more minutes to run all this. But you can see here that no, it will get all this value. So by looking at these numbers, it might be a bit difficult to analyze things. So let's see the plot here. So this is our plot, forecast plot based on history and future. And if you also look at the exclusive forecast plot, so based on these two plots, the ARNet model looks more realistic here, makes more realistic predictions. So you can see some more realistic predictions here, and it also managed to capture the uneven lines in the movements of the stock market. So that's an amazing beauty of this ARF model. So it has captured all these uneven lines, the movements in the stock market. So this model is perfect so far. I mean, like this is at least a pretty good model comparatively with what we have seen in trends and seasonality. So, so still, we can also improve our model by taking recurring events into the consideration. So what do you mean by recurring events? So most often by doing forecasting problem, we should take real events into the consideration. So real events are nothing but if those are nothing but if there are any holidays that are impacting our stock price. So this is what we are doing now here. So I have initialized my model. Then I am configuring my model to take the dates of the holidays into account and see whether we have any impact of our stock price. So apart from that, I'm also passing two parameters, which is the lower window, upper window, which is nothing but, so I want my model to take the previous day and the next day of the prices impact the prices as well. So what I mean here is, for example, if today is a holiday, I want my model to see whether there was any impact of prices of yesterday and whether there was any impact of tomorrow as well. So I want to take those things as also into the consideration. So by giving these parameters as well. So that's it. Then again, I'm fitting my function. So once I execute this, we'll also get this loss values, mean absolute error, all these things. So let's look at this plot. So once I execute our forecast plot here, so it looks more realistic again. And when I also look at the exclusive forecast plot here, it still has captured some uneven things here. But when you compare these two plots with ARNet plots, actually there is no impact in our model. I mean, like there, even though it has considered the holidays here, so the holidays here are nothing but so since it is one thing, sorry, I forgot to mention here, it's Indian holidays because Nifty index are based on a national stock exchange, which is an Indian stock exchange. That is the reason I have taken Indian holidays. The thing is, it should also show here that what are the holidays which are impacted here. So I don't know why it is not showing, but in general, it will show you the holidays of no dates which were impacted on this particular model. But when we look at these results here, it seems like there is no impact on them. The holidays were no more not impacted by our model. So it seems like it looks similar with the ARI model. So finally, what I want to conclude here is predicting a stock price is not that easy. But however, our model has done a good job in terms of capturing a common increasing trend in the movement of the stock market. So that's I mean that's a good thing we have done so far. Of course, due to the day-to-day volatility of the stock market, I would highly not recommend to use this model for your own trading. But I believe that this is a good demonstration of the capabilities of explaining the neural profit. Lastly, there is so much more that you can do with the neural profit, but hopefully this is plenty that you can get started with a neural profit. So that's pretty much about my demonstration. Let me switch to my slides once. Uh, so here is a roadmap for our neural profit. Sorry. So here is a roadmap for our neural profit, which means so one important thing you should remember is this library is still new and there are a lot of changes can happen. Not please remember that not all the features from the profit original profit are already implemented in the neural profit. For example, so if you see, so these are the new features that are yet to be added, like logistic growth for trend components, support for panel data, incorporate time series feature for improved forecasting accuracy, model bias modeling, unsupervised anomaly detection. So all these features are added in the neural profit. So you will also see even more better things in the neural profit in the future. And finally, here are the good references for exploring neural profit. So you can check out their page, GitHub repository, and ARNet library page. And here is also a very good article about the difference between the profit and neural profit. You can check them out. So feel free to explore and experiment in neural profit library, and let me know if you find anything. If you have done something interesting on your profit, I'll be happy to look at, and I'll be happy to learn things from that. And yeah, that's pretty much from my side. Thank you. It's always it's always good to take the time to take seriously. So that's pretty much from my side. And if you have any feedback or any comments or any suggestion, anything for me, feel free to reach out to me on my social media. So here are my social media, here are my channels. it's KP Flow on Twitter, and Kalyan Prasad, you can find me on LinkedIn. Anything, any feedback, I will be happy to take, and really appreciated your suggestions, inputs, and everything. Yeah, and that's all from my end. And I'm open to take questions if you have anything, or if I also have time. Yeah.
Right. Thank you very much for your talk. We have about 5 minutes for any questions. So if anyone does have anything, you know how to do that by the Discord bot.
Okay.
Give people a minute or two, see if anyone has any questions. Okay, it doesn't look like we're going to get any questions, but thank you again for your talk. Thank you very much for stepping in on such short notice. And
thank you so much for PyConZA for giving me the opportunity and to speak and share my knowledge. And if you have any questions, I'll be around. So feel free to jump in the Discord. I'll be happy to answer. And thank you so much, Neil, and the organization team of PyConZA. See you all around. Thank you.
All right. Okay. We'll end the broadcast. Yeah.